Welcome to NASA Launchpad. I'm your host, Amber Whalen. So, let's talk test. Model test, wind tunnel test, flight test. These are all pretty big deals for NASA researchers and engineers. Just like your physics tests are a big deal to you. Let's think about this for a minute. Why do you take tests? Forget grades for a second. You really take tests to make sure you understand concepts. And when you understand a concept, you can apply it to other areas. Now, for a lot of NASA tests, they aren't actually testing the final product. In most instances, they're testing models, either on the computer or with three-dimensional scale models. Why not just build the whole thing and test it? Well, let's talk to Amanda Cutright, mechanical engineer at NASA Langley Research Center, to find out a little more.
We test models because we don't actually have all the pieces of the operational vehicle ready to go. They're still being designed and the design is continually evolving. So we have models and representations so we can test some of those components in a logical order so that we can learn more about the components. We have to keep in mind we're designing a new spacecraft launch vehicle to take the astronauts to the moon, Mars, and beyond. There's a lot of things that we have to learn in stages. So by having these models, there's a lot of things we learn from a technical standpoint about the systems and the design, and we're learning how to better design what's going to be the final product of these models. So we learn things from a technical standpoint, we learn things from an analytical standpoint that all help in having a good end product.
Makes sense, right? It's better to learn about something as you go and keep applying the knowledge you've gained. Same reason you take quizzes, then tests, then exams. Each one builds upon what you've learned in the class and previous tests. What kind of test do you like the most? Multiple choice, fill in the blank, true or false? But you don't always get that kind of test, do you? It depends on which format is best suited for the information you're being tested on. And like I mentioned before, NASA uses a lot of different kinds of tests. Computers, scale models, which one's best? Amanda?
Having a computer simulation and a model are both good. You need to compromise them both. The analytical models, when you have a new design, you can go through a lot of iterations to check different design ideas and concepts and solutions. But you get to a point where you have to verify that analytical model, and that's where the flight tests come in. So they can take the results from the flight test, compare them to the analytical model, and that will improve the fidelity of their analytical models going forward into the future.
So, when you're working on a project for school, how do you know how you're going to be graded? Usually you're given a rubric or a set of guidelines, right? Well, how do you think NASA engineers know how to design their flight tests? They're not just pulling ideas out of the air. So, how do they know when they've got a good idea? Well, each flight test has its own set of guidelines.
An effective flight test article is designed specifically to the goals and objectives for that particular flight test. So different flight tests are going to have different aspects that they're looking into. So there are requirements that scope what is going to be done in that project, and a good flight test article meets the requirements and the design intent of the flight test.
So how about we look at a specific example? You might remember us talking about Ares 1X here on Launchpad. Well, what can we learn from that flight test?
There's a lot of things you can learn from doing the Ares 1X flight test. It'll be the first test of the full stack-up of the Ares 1 launch vehicle, and all kinds of mission objectives and goals that are specific to that flight test. But from a general standpoint, the people working that project learn everything from the technical data that they get from the test, as well as the logistics and the ground operations that they'll need to conduct, and the configuration of the launch pad.
You know, I hadn't thought about that. These tests aren't just about getting the rocket ready. They're also about making sure that everything is ironed out on the ground. Mission control, support, data collection, all that kind of stuff. Really, when you think about it, there's a lot of effort going into these missions, and it's not all from rocket scientists. That means there's a lot of positions that need to be filled, maybe by you.
My advice to students right now who are interested in these careers are to do similar to what I was fortunate to do, and go out and talk and find these people that are working in these careers now. Be curious about what they do, ask them how they like what they do, and get a variety of perspectives from different people and see what interests you the most and try to pursue that. Also, there's a lot of opportunities at NASA as an agency as a whole for students to get involved in real-world work with engineers and scientists to get that experience directly.
So, keep being curious, keep asking questions, and keep learning. Someday you might just find yourself designing a new rocket or its model, and hey, You could be the one pushing the buttons that launches a new era of exploration. Well, that's it for today. Thanks, Amanda, for all the information. I'm Amber Whalen, and we'll catch you next time on NASA Launchpad.